Welcome back. We are going to talk about 0.2 today. And 0.2 is talking about exponents. So this is the second item in our order of operations. So remember, order of operations, we have grouping, exponents, multiply, divide, add, subtract. Today we're going to talk about the second thing, which is exponents. Now, what's it mean to be an exponent? An exponent is a number that tells you how many times to multiply the base. Okay, so with an exponent, like I said, we have a base, and then we have our exponent. So base would be a big number, and then this exponent is a little number. It's called a superscript. So like 4 squared. Okay, 4 is your base, 2 is your exponent. This tells you that you are going to take 4 times itself twice. Okay, so an exponent is a number that tells you how many times to multiply the base. Okay, now we have two types, or we're going to talk about two types of exponents. We have both positive and negative exponents. So in this case here, we have a positive exponent, which is good. If we ever have a negative exponent, let's say we have 1, or let's just say we have a to the minus 1. We do not deal with negative exponents, okay? There's only one time that you will ever deal with negative exponents, and that is scientific notation, which we will also talk about. But in order to get rid of a negative exponent, I use its reciprocal, okay? So a to the negative 1 actually means 1 over a to the first. Okay, that negative puts it on the other side of the fraction bar because this is over 1. In order to get rid of the negative, we turn it upside down. Just like if I had 1 over x to the minus 4. In order to get rid of this negative, I have to find the reciprocal of this, which is just flipping it over. So it would be x to the 4th. Okay? You will want to know how to get rid of negatives. We do it a ton. Okay? So once you get rid of the negatives, that's when you can go ahead and evaluate the exponents. There's some properties I want to go over with exponents really quick. We will talk about the product property. That is like x to the second, x to the third. We will talk about the quotient property. That is like x squared over x to the third. It's really division. Power property. That's like x squared to the third. I call it a power to a power. And then we have product and quotient powers. So I'll put that over here. So we have product, so multiply and divide powers. That's like xy squared or x over y squared to the third or to the fourth. Okay, so with a product property, if the bases are the same, you're going to multiply the exponent. So that's you're going to add the exponent. So that's 2 plus 3, which is x to the 5th. Okay? Here, I think of this a little bit differently. I think of this as how many x's do I have in the top and how many do I have in the bottom? Where are there more? And that's where they'll be. So I think of this as like there's 2 x's in the top, there's 3 in the bottom. These will cancel, and you're left with 1 x in the bottom. Okay? A lot of people just say you subtract them and then put them wherever the bigger number is. To me, this is just easier to visualize. Okay. Power to a power, you just multiply the exponent. So this is x to the 6th. Okay. And with these, okay, we have to go back to the definition. The definition of an exponent says you take it times itself that many times. Okay, so we're going to say xy times xy, and you have x squared y squared. Here you have x over y times x over y, which is x squared over y squared. We never, let me write this down, because this is super important. We never distribute I might have spelled it wrong, but we never distribute exponents. Okay, if a teacher told you that before, I'm sorry. You do not distribute an exponent. Okay? Never, ever, ever distribute the exponent. Okay? There was one more property. It's called the zero property. And that says that anything to the 0 power is 1. Okay, anything. All right. So I got some steps here on how to simplify with exponents. So exponential expressions. Step 1. You are going to do any parentheses. Okay, eliminate parentheses. Step 2, you're going to make sure you're going to combine your bases. Okay, so I can only have one base x. Step 3, no power to a power. Okay, and step 4, positive exponents. Okay. Those are how you know when you are done simplifying a fraction or an exponential expression. Let's talk quickly about scientific notation. Okay, scientific notation is used to write big or small numbers. Really big or really small numbers. Okay, so if I have some number that is just really small, let's change that to 0. Okay, I'm going to write this using scientific notation simply by counting how many times I need to move my decimal. So that is 1, 2, 3, 4, 5, 6. This first number, I'm going to go until I hit this first non-zero number. So that is 1.001357 times 10 to the negative, and then 1, 2, 3, 4, 5, 6. Okay, a negative exponent represents a really small number. If this is a positive exponent, that means it was a really big number. Okay, so kind of refresher on that. You should have had that already, but if not, we'll look at reviewing that. Okay, so here are your 0.2 questions. So how do I get rid of a negative exponent? What's it mean to be an exponent? a to the 0 equals what? And I'm actually going to add 1. We got 4 on this one. So 4. What do we never do? Okay, here are your suggested problems. Okay, go ahead and write those down. If you want to get started on those, go ahead. There's not very many of them. We will discuss this further. We'll do more examples in class. So get these answered for class. Start on the suggested problems if you would like. This is your stopping point for class. So if you are going to be in class the next day, stop here and you will get the rest in class. If you were gone, please continue to watch as I'll do examples. And if you're just so eager and can't wait, go ahead and watch. But for those stopping, this is at THS Mr. Jones signing off. Okay, if you're sticking with me, we're going to do some quick examples over 0.2. Okay, with just some exponent stuff. So real quick, just kind of going over what it means to be an exponent. So if I have 4 to the third, that means I'm taking 4 times 4 times 4, and 4 times 4 times 4 is 64. Okay, so you're taking this exponent tells you how many times to take this base by itself. Okay, so we can do it with negatives. There's 2 different ones here. These will give you 2 different answers. So you have -3 quantity to the 4th and -3 to the 4th. This means that you are taking -3 times -3 times -3 times -3, which will result in a positive 81. And then here you're taking a 3 times 3 times 3 times 3, and it's negative out front. So this is actually negative 81. So be very careful with where those parentheses actually go. Okay, we had discussed some negative exponents. And with a negative exponent, in order to get rid of it, you just move it to the other side. So if I have 2 to the -4th, I'm going to take 1 over 2 to the 4th. If I keep going, that's 1 over 2 times 2 times 2 times 2. And that is 1 over 16. We can do it a little bit backwards here if I give you a little bit harder problem. A little more complicated, but that's a 2. Okay, so first I'm going to get rid of this negative exponent. So this will be -2 to the 3rd still. Times, if I take this whole thing and move it to the top, that is -6 squared. Okay, so this is -2 to the 3rd, but only the 2 is appearing 3 times. And this one, the -6 is appearing twice. So that's 2 times 2 times 2, which is -8, times -6 times -6 is -36. That's -8 times, oh, that's a positive 36. So -8 times 36 is -288. Okay, so be careful with moving those positive and negative exponents. Okay, we talked about the zero product property. That means anything to the 0 power is 1. Okay, so that's x to the 0 equals 1. Anything to the 0 power is 1, so we can kind of just get rid of it. Now, the real fun in this topic is problems like this. So we'll look at 2 problems. And let's look at this one. Okay, so I'm going to simplify both of these. Okay, so in order to do that, we're going to combine and we're going to simplify our coefficients, which are the big numbers. So I'm going to take -2 times 5, that's -10. Okay, and then since we're multiplying we're going to take x squared, x to the third, y third, y. Okay, I could have wrote negative 2 times 5 over here, but in this case we are multiplying. So since my bases here are the same, we're going to add the exponents. So I said minus 10x to the fifth, add exponents here, that's y to the fourth. Okay, since I have no negative exponents, since my bases appear ones, since I don't have any parentheses and no power to a power, we are finished. Okay, here we will divide the coefficients, so that's 25 divided by negative 5, that's minus 5. I have x's on top and bottom. Well, if you look at this, there are more x's on the bottom. Okay, and how many more are there? Well, there are 2 more x's on the bottom, so I write x squared. Okay, with y's, there are more y's on the top. In fact, there are 2 more y's on top than on bottom. Okay, so 4 of them would end up canceling out. So that is why we write it as such. Okay, let's get a little bit more difficult one here. Let's say negative 2xy squared to the third over negative 6xz to the third squared. Okay, so with this extra power up here, this tells me that this appears 3 times. So I'm going to write it out 3 times. Okay, and in the bottom, this in the parentheses appears twice, not the negative out front. So we'll put the negative out front. So 6x z to the third, 6x z to the third. Okay, now we're just like I was up here. We're going to combine what's in the top, combine what's in the bottom. So I have negative 2 times negative 2 times negative 2, which is minus 8. I have 1, 2, 3 x's, so that's x to the third. I have 2, 4, 6 y's. In the bottom, I have 6 times 6, which is 36, but I had the negative out front. I have 1, 2 x's. I have 6 z's. Okay, and then I cancel where I can. So I have negative 8 divided by negative 36, which will turn to 2 ninths. I have x's on the top and the bottom, but there's one more on the top than the bottom. And my y's, nothing happened with the y's, so they stay. And I don't have any more z's, so they stay. And then that is my answer. 2x y to the 6th over z, 9z to the 6th. Okay, we talked about scientific notation, a way to represent really big or really small numbers. So we can just look at how to write one real quick. So if I have this number, okay, in order to write that in scientific notation, I will take and move my decimal place until I get a number between 0 and 10, less than 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spots. So that means I have 10 to the 12th times 3.875. This exponent is positive because it was a really big number. Okay, remember, power of 10 just moves your decimal left or right. Okay, if I give you something like this, let's say I give you 1.03 times 10 to the negative 6. Okay, because this is negative, we're talking about a really small number. Okay, smaller than this. So in order to get smaller than this, I need to move this decimal place to the left. And I need to move to the left 6 times. So 1, 2, 3, 4, 5, 6. And then put in your zeros. So that is 0.000000103. And that is your really small number. Okay, that's going to wrap it up for chapter 0.2. I hope it was easy for us. Again, there are your questions. There are your suggested problems with your challenge problem. Okay. If you got questions, please let me know. I'm here before and after school. So just let me know. As always, this is at THS, Mr. Jones, signing off.